Okay, so welcome viewers. In the previous video lecture, we saw this thing that delta does not behave like derivative operator when it is applied on a general polynomial. Okay, so now in this case, we want to apply delta on factorial polynomials. Okay, so take this factorial polynomial f of x equal to x square factorial. Okay, so you see that f of x equal to x square factorial, x square factorial, this is equal to x into x minus 1. Okay. Now, this can be written as x square minus x. Now, if I apply delta on this function f of x, so it is equal to f of x plus 1 minus f of x. So what is f of x plus 1? It means that you change x to x plus 1. So it is x plus 1 whole square minus x plus 1, okay, minus f of x, minus f of x. So what is f of x? It is x square minus x. So apply here a plus b whole square formula. So it is a square plus b square plus 2ab minus x minus 1 minus x square plus x. Okay, so x square cancel with each other, minus x plus x cancel with each other, minus 1 plus 1 cancel with each other. So here you are left with only 2x. So 2x can be written as 2 times x raised to the power 1 factorial. Okay. So you see that when you apply delta on x square factorial, okay, so it is equal to 2 times x raised to the power 1. So it means that delta behaves like derivative operator when it is applied on factorial polynomial. Okay, so what I feel key you people have understood this thing. Now see some important results. Suppose that here you have delta square and x raised to the power 2 factorial. Okay, so by delta square we mean that we want to apply delta twice on this x square factorial. Okay, and we are already aware that delta behaves like derivative operator. Okay, so delta square can be written as delta into delta x raised to the power 2 factorial. Okay, so what is the derivative of this function? So it is 2 times x raised to the power 1 factorial. Now again find the derivative of this. What it is? It is 2 only. Okay, so 2 can be written as 2 factorial. So what conclusion I draw from this, that whenever the power of delta and the power of polynomial, okay, both these are same, then it is equal to this numbers factorial. Okay, so this is the answer. For example, delta cube, okay, x raised to the power 3 factorial. So what it is equal to 3 factorial. Okay, it is equal to 3 factorial. Likewise, if we apply delta raised to the power n on x raised to the power n factorial, so this is equal to n factorial. Okay, so if somebody asks this question, that what is delta 2005, okay, x raised to the power 2005. Okay, see, this is a general polynomial, but if we convert it into factorial polynomial, then degree always remains same. I have told you this thing in the previous lecture. So whether you apply delta on factorial polynomial or whether you apply delta on general polynomial, when there when the degree of delta and degree of polynomial it remains same, in that case the answer is equal to this powers factorial. Okay, otherwise it is not possible. But when degree of general polynomial or factorial polynomial is same as the degree of this delta, In that case, the answer is this powers factorial. So you people remember this thing. For example, delta raised to the power 6 into x raised to the power 6. It is what? It is 6 factorial. Okay. Now, after this, we want to discuss one more result. Suppose we apply delta more number of times than the degree of the polynomial. Okay, so take this example. So it means that here we are applying delta squared twice on a degree on a polynomial of degree 1. So delta into delta x raised to the power 1. Okay, so what it is, when you apply delta on this, okay, then it is equal to 1. Okay, and delta of a constant, it is always equal to 0. Okay, so this is the very important result. Delta of a constant, this is always equal to 0. Why does this happen? I just show you it in a minute. For example, suppose that your function f of x, this is equal to c. Okay, and you know that what is delta of f of x, this is equal to f of x plus 1 minus f of x. So f of x plus 1 means that in your function you change x to x plus 1, but as there is no x here, so you cannot change it. So it is c minus c, so which is equal to 0. So delta of a constant, it is always equal to 0. Okay, so that is why I am using this result here, that delta of 1, it is equal to 0. I repeat, delta of a constant, it is always equal to 0, but e of a constant, it is a constant. Okay, e of a constant, it is a constant. Now if you apply delta on suppose 10, it is again 0, but if you apply e on 10, it is 10. So from this we conclude one thing, that if the degree of delta is more than the degree of the polynomial, okay, then answer will be equal to 0. Okay, now see one more result of this, right? For example, suppose we have here delta raised to the power 2005, and here we take one polynomial of degree 2004, okay, plus 1. Now you see that the degree of this polynomial, it is less than the degree of this delta. Okay. So what is the its answer then? Its answer is, okay, its answer is 0. Now next we want to talk about particular particular solution. Okay, particular solution. See, a particular solution is that solution which does not contain any, constant. Okay, so what we do, we will talk about it in the next video lecture. Okay, so thank you very much, students.